right, welcome back. Unfortunately, I did have to cut to a part three, but the good news is that we are almost done. We're still looking at global cycles. We've already looked at the carbon cycle, but this is what happens on a big scale. Um, Most of the Earth's carbon is tied up in sedimentary rock. But the portion that we do use, the portion that's in the air, is the part that sustains all life on Earth. Without carbon, there would not be life. 93.2% of that carbon is found in the ocean. 3.7% is found in our soil, 1.7% in the atmosphere, and 1.4% in vegetation. So you can see from this chart here, this is the billions of tons of carbon that are cycled. Most of that carbon is going to come or cycle through surface to air or sea surface gas exchange. That's what's happening here. And the second largest is going to come through photosynthesis, where carbon is taken out of the air. We'll see a difference of that in just a second. The rate that biota exchanges carbon dioxide with the atmosphere is estimated around 300 years. However, since the Industrial Revolution, sedimentary carbon has been added to our atmosphere at an alarming rate. Again, most of carbon is stored in sedimentary rock. A huge portion of that is in fossil fuels, oil and coal and natural gas. And when we burn those fossil fuels, we release all of that carbon into our atmosphere, and that is a major cause of concern when we look at climate change. This is another representation showing you the numbers of carbon movement, and this is in gigatons of carbon per year. And the arrows here are done so that you can see the sizes of what's going on. So carbon is taken out of the atmosphere by the ocean. It's stored in the ocean. It's also taken out of the rock through erosion and put back into the ocean. Plants take up a pretty sizable part here, 3 gigatons of carbon per year. Plants are taking carbon out of the air. Land use puts carbon back in the air. So if we look at just this part of the cycle and this over here, I should have more carbon exiting the atmosphere than I have entering it. However, since the Industrial Revolution, 6.3, now remember this is in the 1990s, 6.3 gigatons of carbon per year is released back into the atmosphere from fossil fuels. You see this big giant arrow here. This is why carbon dioxide has been on such a drastic increase over the last 50 years. This number is a low estimate because, again, it's from 13 years ago. The more or what is that, 23 years ago, sorry. The longer we use these fossil fuels, the more carbon is put into the air. And unfortunately, photosynthesis and the ocean air exchange is not able to keep up with those levels. Nitrogen is exchangeable, once again, mostly through bacteria. 99.4% of nitrogen is found in our atmosphere. 0.5% is in our ocean, 0.04% in detritus or decaying matter, and 0.006% is inorganic nitrogen, usually in the soil. 0.0004% is in living biota. So we don't need a lot of nitrogen to survive, but we do need nitrogen. Again, without it, we don't have DNA and we don't have proteins. We are disrupting the nitrogen cycle tremendously by adding huge amounts of nitrogen to the ecosystem. Power plants and automobiles add nitrous oxides. And those are deadly chemicals, and they disrupt the nitrogen cycles tremendously. The other source of nitrogen deposition that is huge is in fertilizers that we've talked about before. We add a tremendous amount of nitrogen to our soils, and that nitrogen ends up running off into the oceans and increases the nitrogen content there. As we face these problems, scientists are currently looking into the response of native and natural plants and ecosystems to nitrogen deposition and global warming. These two issues are a major area of concern for environmental scientists. How are our plants dealing with this excessive nitrogen? And we will be studying that when we get to agriculture and when we look at water and air pollution. Here's a representation of the nitrogen cycle using those arrows. You can see the largest cycling happens in the ocean. This is between bacteria, typically, where I've got bacteria and algae that are taking in nitrogen and breaking it back down. We also have internal cycling happening between our soil components that are fixing bacteria and the plants and animals that use it. However, I do have nitrogen being fixed by atmospheric nitrogen being fixed by industrial pollution. This is our nitrous oxides. Um, and this is industrially and with cars that are taking all that nitrogen that is not harmful, that's floating around 78% of our atmosphere, and turning it into these toxic chemicals. In general, what you need to remember, I know this has been a long session with 3 separate videos, but what you need to know and remember are each of the steps of all the nutrient cycles. The hardest to remember is the nitrogen cycle, so please do go back over that cycle until you know the steps. Don't be afraid of the chemistry. That's the hardest part about this, is knowing the difference. What is nitrate? What is nitrite? Knowing the different terms and knowing how those are represented. Know your scientific nomenclature. We need to look at how all these cycles are related. None of them happen by themselves. All of them are related to one another. How does the water cycle contribute to the carbon cycle, and how do all of these cycles interact? We will study that in class extensively, so if you're not seeing those connections yet, that's okay. And the second part of what we're going to study in class is how do humans contribute and disrupt the nutrient cycles. I've touched on that a little bit with atmospheric pollution from factories and cars, and with nitrogen deposition from agriculture. We will study that much more extensively in class and look at the effects of disrupting these cycles in nature. So again, I know this was a long session. Please make sure that you have taken notes or printed out the PowerPoint for this so that you've got something to study, and we will study these in class. If you have any questions at all, please feel free to ask them at the beginning of our next class section. I will have a Q&A session before we get started. Thank you very much, and I hope you enjoyed it.